Alright, so now let's move to the two-dimensional problems. Now we want to discuss so-called beam problems here. The chapter 4 is for beams, and this is really important. And in actually after your graduation, so you would encounter many problems associated with this beam behavior. So basically, in this chapter, we're going to talk about, especially for the bending moment, so-called bending moment. Bending moment in 우리말 휨 moment, and the shear force, 전단력. 휨 moment and 전단력. We want to discuss how we calculate the 휨 moment and 전단력. Alright, so this is the outline. Again, the how to tackle a mechanical problem is exactly same even for this beam problem. So we have to use the force equilibrium and then material law and displacement compatibility. There is no change, okay? Please trust me. In any kinds of problem, we always use these three conditions. No exemptions, okay? No exemption. Although of course we have to touch, the boundary conditions to close the problem, but it's always same. And then we have to deal with two different scales, structure scale and the material point scale. That's it, okay? Very simple. And then the learning objectives here, so we want to discuss the concept of internal forces and moment in beam found in beams and frame problems. And then also we'd like to define the types of beams and different names of beams depending on the load conditions and support boundary conditions. And then we're gonna discuss so-called internal release. Internal release in 우리말은 내부 지점, okay? 내부 지점. That's good internal release that can exist beams and frames. And then the internal release should be included, should be considered in the analysis. And then also we'd like to make a relation between the internal bending moment and the internal shear force in terms of the differential equations. And we'd like to learn how to construct the shear force diagram. The shear force diagram is simply we call SFD. Okay, this is called the shear force diagram. In 우리말, it is called 전단력 선도. 전단력 선도. And then bending moment diagram, BMD. Bending moment diagram. And the 휨 moment 선도. Actually, please make sure that here there's a word is omitted here. So make sure that, so we are talking about the internal, okay, internal. So not the external, okay, not the external. So now you understand the external forces are different from internal forces. Okay, they are completely different, okay. That's why we use different sign conventions. Then what are beams? The beams are the structural members subject to lateral loads. Okay, the direction of loading is not parallel to the longitudinal direction of the members, but is in the lateral direction. Okay, so all the loads and deflections occurs within the same plane, which is called planar bending. In 우리말 planar bending is 휨평면, 휨평면, planar bending. And then the girders, 보조포 아니면 우리말 girders. Girders is another name of beams, okay? Girders supporting gravity-driven loads are classified into beams, okay? And the loads on beams may include concentrated loads, okay? And then the distributed loads. We can consider both of this. Okay, let's consider an example of concentrated load that we have to consider. Let's consider a girder, a bridge girder. This is a bridge girder. In 우리말 it's 교량 girder. And then say it support a vehicle. Okay, and then vehicle can be replaced by a set of concentrated loads. Okay, that's how we consider the concentrated load. And then of course the beam the beam should be made of some materials, then it is subjected to its own weight, isn't it? Yeah, its own weight. That's why the weight, its own weight, can be represented by distributed load. Okay, distributed load. Okay, so that's why in beam problems we should be able to handle both concentrated loads and distributed load. Do you understand? Okay, this is the characteristics of beam problems. Do you have any questions? Okay, so here let's take another 10 minutes break before we talk about the boundary conditions and types of beams.